Hi everyone, I'm Hack. This is my demo for assignment 1, network attack covering packet spoofing and TCP session attack in the SIP environment. Now on the first packet spoofing attack, before starting the packet spoofing task, we need to set up the lab environment. The lab container will build using Docker Compile build with outputs confirming the attacker, host A and host B service. Each you reuse an existing local image. The lab topology will launch with Docker Compose F-D, successfully creates this attacker, host A and host B containers. I type docker ps to list all running containers. The output is confirm the 3 containers up, host A, host B as this attacker, and each serve as up about minutes along with their full containers IDs. I run IP address show in attacker container, so it shows the interface and its LAN. And the purpose is to identify the interface connected to the same network as host A and host B. All my Scrappy programs will use this interface because it allows attacker to both observe and inject packets into shared LAN. So the output is confirmed the correct interface and has been identified, so the environment is ready. In Telnet packet sniffing attack, I opened the Telnet sniffing program in the attacker terminal. So the purpose of this script is to monitor Telnet communication between host A and host B. So the most important part of the code is the sniff function. It continuously listens to on the bridge interface, filters only Telnet traffic, and whenever a packet arrives, it passes the packet to a callback function for display. Because only Telnet packets are captured, the output is clean and easy to analyze. Now I execute the script. So the program is now waiting passively for Telnet traffic since sniffing does not generate traffic itself and no packet appear yet. I establish a Telnet connection to host B and log in. After login, I execute several commands such as checking the current user and displaying the networking directory, finally listing files. So these commands generate a real application traffic instead of only the TCP handshake. Returning to the attacker machine, we can now see the captured packets. The script successfully captured every Telnet packet exchange between host A and host B. So this proves that the attacker can observe the communication. And I finally verify the capture using Wireshark. Make sure you choose the right interface and open in the whole process. We can clearly observe the TCP handshake followed by Telnet application data. And more importantly, the Telnet payload is readable because Telnet provides no encryption. I'm using TCP flags filter, and it shows 2 frames, host A since and host B since act. So both spoofing attack I'm about to show rely on the same fact is the TCP accepts whichever packet has the correct sequence and act numbers. It never checks who actually sent it. Next, I demonstrate ICMP packet spoofing attack. On the attacker, I open ICMP spoofing Python. The purpose of this program is to impersonate another host by generating forged ping relays. So the key part of this code is listen for incoming ICMP echo request. When one is detected, the script copies the identifier, sequence number, and payload, create a forged relay pretending to come from the target IP address, and immediately send it back. Now I execute the spoofing program. So the attacker is now waiting for ping request. Then I switch to host A and ping the target IP address. Although this address does not belong to any real machines, the attacker will generate the response. Returning to the attacker terminal, every ping request is immediately captured. The program generates a swift reply for each request. So the matching identifiers and sequence number makes the reply appear completely legitimate. Looking back on Jose, every ping succeeds. The operation system believes the destination host exists even through no real machine own that address. So this proves the spoofing attack is successful. At the same time, the White Shark also confirmed the result. Every request is immediately followed by a forged reply. So this independently verifies that the attacker generated all responses. The future ICMP show clean request and reply pairs. So opening the forged reply detail pans shows the Ethernet source MAC matching the attacker own interface, while the IP layer claims to be 1.2.3.2. That mismatch is the proof of forgery, because a ping never checked layer 2. Now let's moving on to TCP section reset and hijacking attack. So I start with Docker compose up -d, which create and launch 4 container in detached mode, seed attack, host C, host B, and host A. These 4 container correspond to attacker, match, and these 3 victim hosts representing on the same LAN. I use Docker VS, so the output exposes the container ID for each running container, which the value need to reference container in the Scrappy-based command uniquely. Now I enter the attacker container. So I run if config to confirm the interface that carry the innet 10.9.0.1, validating it as a correct interface for sniffing and spoofing traffic. On host A, I telnet to host B and giving the attack a leave session to the target. In the attacker terminal, I open TCP RSD attack Python. So the key RSD attack function sniff one leaf packet, then send 2 spoofed RSDs, one as host A to host B using sniff sequence plus payload length, one as host B to host A using sniff ACK number. The 2 packet, because TCP is full duplex, closing one direction alone leaves others to open. Now I run the script log. Before I run the script log, let me sure I open the White Shark. Make sure you choose the right interface. I run the script logs, the sniff sequence, and ACK number. They confirm both reset sent. On host A, the telnet section shows connection closed by foreign host with no input from either user, confirming the kernel accept the forked RSD because the sequence number match exactly. In one shot, I filtering TCP port equal 22 and IP source is host B is show 2 RSD frame with sequence number match with the script report. We finally moving to TCP section hijacking. So this is the most important attack, injecting a command into an already authenticated session without touching either machine directly. So on host B, I manually write a baseline file so I can later prove that injected version was typed by me. And also on host A, I will open and leave a live telnet session into host B since the hijacking needs the unterminated stream to write on. Also, in attacker terminal, I create the TCP section hijacking Python, and the key line is here, the next sequence equal to sequence plus data length is predicting exactly what host B expected next from host A. The scripts forge the packet with the host A IPs that predict a sequence number, PSH, arc flags, and a shell command payload. I'm running a log sniffer sequence, the calculated next sequence, and successfully injection. So on host B, I will cat home state and my S number. So as you can see, it shows identity string from injected command, proof it was executed by the shell, not just accepted at the packet level. And in the Wireshark, featuring both hosts on post 22 show a burst of retransmissions right after the injection point, the fingerprint of 2 sides filling out scene. To summarize, every attack here exploited the same gap, telnet, ICMP, and TCP, all check whether a packet is internally consistent, but none verify who sent it. So this is the end of my demonstration. Thank you for watching.